Hello everybody, this is a video tutorial about Agileto mobile network optimization software tool. More specifically, we are going to talk today about BCCH channel allocations, audit and optimization. Actually, we are going to see how we can allocate and optimize mobile network on 2G technology, specifically which are the absolute radio frequency channel numbers which are going to be allocated for each cell. So let's start with a short description about this. It's about let's say what is called absolute radio frequency channel number, as you can see here, and this is a number that is allocated for each cell. It is going to be in different frequency bands. In GSM 900 MHz we have public GSM or enhanced GSM band. So these are, and there is a GSM-R from railway, less used for the public networks, so not really used, it's just for the railway system. So basically most often we are going to discuss about PGSM or EGSM 900 MHz band, or GSM 1800 MHz or 1900 MHz, what is called DCS 1800 or PCS 1900. So in terms of the absolute radio frequency channel numbers which we can see here, these are going to be divided in two sub-bands for the GSM 900. From 1 to 124, this is for the normal GSM, let's say public GSM standard, or enhanced GSM that is going to have another dedicated band from 975 to 123 ARFCN channel numbers. So this is a formula how you can calculate uplink frequency and respective downlink frequency according with the number, with ARFCN channel number for both bands. So this is just a general overview about what is absolute radio frequency channel number and which are this number which are going to be used in order to transmit the BCCH frequency. This is something that you can see in Wikipedia, and it's very simple. You can just browse Google anytime and you can find this information very easy. So now if we return to our project, let's say we start Agileto, and we want to be sure that we are discussing initially about Agileto demo project, which is delivered together with the Agileto installation kit, and you can have some examples about different technologies, 2G, 3G and 4G. Now we are focused on 2G technology. So just be sure, if you want to replicate what we are doing now on this video tutorial, you have set up here the, let's say, Agileto working path C Agileto, and the active project is a demo project. So okay, in order to see how looks let's say the network, the 2G network, we are going to open the demo project mobile network. For this reason we choose this in Google Earth. We open it and we will see immediately how it looks like. Okay, these are the sites related to the 3G technology. We are going to deactivate this and let's activate the 2G technology. What you can see here, these are the BCCH channel allocation. For example, in this case 40, 44 and 39 for this GSM demo 1 site. For this case you have 40, 35, 45 for the site called GSM demo 4. So if we click on any cell, we can see, for example, here we have the BCCH 40 that is represented here. Here you can see the BCCH 44 that is here, and so on. You can see everywhere which are the BCCH channel allocation, what we call the ARFCN, so absolute radio frequency channel numbers. So now if you look normally to this, it is good not to have the co-channel interference, means two cells sharing the same ARFCN, or let's say we are going to say BCCH number. For this reason, there is a specific dedicated module that is called on this Audit and Optim section 2G BCCH allocation audit and optimization. If we open this module, okay, we just say okay, we click OK. We have this information, and this information is going to present different information on this window, and basically you have here on this area what was automatically detected to be present on the 2G network. For example, we see that we have the GSM 900 band with the BCCH limits between 12 and 59. So if we want to return here for the GSM 900, we can see that we can have let's say the normal channels between 1 and 124. In our case, the minimum, because it is used for one operator, can have only one interval, one range where it has been given a certain, let's say, number of frequency to be used on its network. In our case, we have this from 12. This is a minimum, let's say, channel allocation, and the maximum is 59. Obviously, if we want, we can extend, we can increase the maximum value available to another value if we want, or we can decrease the minimum value between between 12, what is automatically detected, and 0. But let's say we are going to keep it like this. Extended GSM 900, it was not detected, so that's why it is not ticked here, and there is now minimum and maximum channel detection, and for the DCS 1800 limits, we have seen that we can have let's say for the DCS, the absolute radio frequency channel number, BCCH numbers, are between 512 to 885. This is a standard that can allocate between this number for the absolute radio frequency channel number. In our case, we have the minimum allocation to be 701 in our database, and the maximum is 789. So if we want to see this, it's very simple. We can see in DCS it's light purple what we have here, so the minimum is 701. We have just two sites, that's why it's very simple to evaluate. The minimum channels is 701 and the maximum channel is 781, as you can see here. So now if we remember These are the channels detected. The same is for the GSM 900. And now let's say that what is how to use this let's say information. We have here, let's say, the possibility to change the selected cell that we want to investigate. From here you can select whatever you want, yeah. So, and once you select one cell from here, all the other cells belonging to the same site that is presented here, this is a reference source data, is going to be present here on the bottom side of the window. And here the same site contain multiple cells. In our case, for example, this site's Agileto demo 5b is this one. It contains Agileto these cells, demo 5a, demo 5b, demo 5c, and you can see here the BCCH allocations are 37, 32 and 46, like you can see here. Now, what is presented on the right side here? This is an automatically calculation related to the which is for example, here in this area we have BCCH co-channels potential interference. So if there is another cell sharing the same BCCH, is going to be displayed here at what distance we have, and these are the information about the cell ID and the lock that is sharing of the other cells, the closest cells sharing the same BCCH value. If no one is detected, it is our case, it is supposed that we have, let's say, a very high distance, standard it's 1000 kilometers, and here we have the information if we have inside of the beam width the relation between source and target, means if this source cells is pointing to the target cell detected here. But let's do, and the same information is calculated for the BCCH adjacent channel inferior, and here this is in yellow, let's say, background, and what we have here in blue background is BCCH adjacent channel superior. So in our case, for example, if we look here, we have the BCCH 46, and we see here one cell which has the cell ID, let's say 34, and the lock 1020, and the name of the cell is Agileto demo 4C. This is going to share the same the inferior channels, means if the channel is 46, the inferior channels is going to be 45, and 45 is shared by this cell Agileto demo 4C. So we see here, this is a cell that we are talking about. So 45, this is a BCCH 45, and this was Agileto demo 5C, the 46 BCCH. And we can see this cells is detected at the distance of 1.2 kilometer in relation with the source cells Agileto demo 5C. So 1.2 kilometers. This is the distance between this cell and this cell. Yeah. Okay, now if we want to allocate, for example, another BCCH, because we want to increase the repetition of the, let's say, or here in this case, the distance for the adjacent channel number, we can play with these values. Let's say we allocate different, if we allocate 41, we see here there is another cell that is going to have, for example, for 50, it is going to be Agileto Demo 7C. So in this case, Agileto Demo 7 is here. Yeah, is here, this one. So now if we want to export all of this information that we have here presented, we just press this button and all the information will be exported in Excel. But let's start something maybe more interesting to present you. Let's start with the beginning. For example, if we select the first cell, Agileto Demo 1A, yes. So in our case, we are just want to. This is Agileto Demo 1, and 1 second, just to present you. Okay, so in this case, for example, we have the repetition of the same BCCH 40 for Agileto Demo 1C on this cell, Agileto Demo 4A. So we can see here, this is one cell, Agileto Demo 1C, sharing the same BCCH 40 here, that is presented as well here, with this cell, sharing the same BCCH 40. So in our case, we see this repetition at a distance of 0.9 kilometers. So in our case, we can have a potential BCCH co-channel interference generated by the fact of two cells sharing the same BCCH number of 40. One is Agileto Demo 1C, yeah, is this one, and the other one, just a second, is Agileto Demo 4A, is this one. So these are the two cells sharing the same frequency, and we see, for example, Agileto Demo 1C, it is inside of the coverage of the Agileto Demo 4C. Now if we want to export this, for example, in Excel, we just press this button, yes, and we have here the same information that is presented here. And this window we can have here in the same cell, the same information. The sector ID, for example, in our case we have the Agileto Demo 1C having the BCCH 40 with the co-channel cell Agileto Demo 4A having the cell ID 32 LAC 1020, placed at 0.9 kilometers distance between them, and one cell pointing, for example, the target cell pointing to the source cell, and that's why we have 1, 0, 1, but not in the reverse way. And after that there is information about adjacent channel inferior. This is what is presented here in yellow background, and for the superior we have the information on the blue background. So if we see here for the inferior channel numbers mean 39, we have the Agileto Demo 1B, that is closest cell in relation with 1C. So this is something that if we want to play and save further this information. What else we can do? This is obviously very easy, very simple to play, and we want to say, okay, which is the best BCCH number to allocate to one of these two cells sharing the same BCCH in order to avoid co-channels interference. So in this case, Agileto is providing automatically a BCCH Optim information based on the distance between the source cell and another target cell sharing the same frequency, or same BCCH. Now, in our case, for this specific situation of repetition of the BCCH 40, it's easy to understand that the optimum BCCH number is going to be provided as 13 seen at 1000 kilometers. Means no other cell is sharing the same, because there is just very small network. The BCCH 13 has never been used in this network. That's why it is presented to be the best one, the optimum one. But what is, let's say, the situation when we are going to deal with the real network, where we have a lot of cells and the repetition of all the channels allocated already on the network is important. So it's not very easy and not very common to discover like this which is the best BCCH channel number, ARFCN channel number, to be allocated in order to maximize, let's say, the repetition of the same BCCH, taking into account as well the in-bandwidth coverage between source and target. So this was very simple because it was a demo project, just few cells and so on. But what we are going to do, for example, if we change the project, for example, if we change the project, let's say we are going to start to select a new project, and we have already a project defined, let's say demo ATT, where we have already a network, and we are going first of all to see how looks this network in Google. Okay, this is another place in another area. Okay, this is, let's say, the 3G. These are the 3G sites, but we don't want to see neither 3G neither 4G. We want to see only the 2G. And if we do something like this, this is something quite real, where we have a lot of information, and what we have here is the representation of the DCS. You see, the DCS 1800. If we want, of course, we can present, let's say, the information as well for the 900 megahertz. So what is in the dark blue, it is let's say the information related to the 900 megahertz band. So we have just selected the 900 megahertz band. Or if we want, we can see just the DCS and with the BCCH allocation for each cell. Now, in this case, what we can do an audit over all the network using the same module, 2.3 BCCH allocation, audit and optimization, and we just go forward. As we can see here, a lot of cells, 10,000 cells here, are going to be detected into this network. And what are the results? The results present here, which have been the, let's say, the detected GSM or DCS band. In this case, this is something that is not relevant because it was not ticked by default. So we have detected just cells into the extended GSM 900 band and in DCS 1800 band. And this this is a full band between the channel 975 and 1023. So all the band have been used, all the channels allocation are used. And for the DCS 1800, there are only from 753 up to 869 ARFCN channel number allocation. Although the possibility to allocate it was between 512 to 885. This is the standard, but this is automatically detected by the tool up to the value detected into the database. So what we can do in this case, we can do initially a general audit. So if we want to do the general audit, we just press this button to do the BCCH audit for the entire 2G network. So if we press this one, we can see that the evaluation is very quick, and we have here, okay, we have an information presented over all the network. Let's have here something like 85%, just to have a clear overview. And here we have two tables, two sheets, one for the GSM 900 let's say analysis audit, and another one for the DCS 1800 audit. And what is presented on each one? On the first column there are the cells information, sign name, cell ID, azimuth, LAC, and BCCH allocation. After that we have information about what is in brown background, the information related to the co-channel status, co-channel potential interference cell status, which is going to share the same BCCH like the source, and which are the cell name, the cell ID, azimuth, LAC, and how it is regarded related to source and target, and where is placed related to the source. Now this cell, for example, is sharing the same BCCH 978 with the source and is placed to a distance of 9.2 kilometers. Now if this is a source cell and is having the BCCH 978, the inferior channels is 977, and the cell sharing this BCCH, the closest cell, is placed at the distance of 8.9 kilometer, and this is let's say geographical and geometrical position, telling if one cell is pointing to the other one in terms of coverage. And the same is let's say for the superior channel. What we have here, it's one second, just to do a proper zoom, let's say 85% just to see everything. So for the superior channels we have everything here with the blue color, and we see the distance of repetition of the closest cell sharing this channel 979 as BCCH has the name of this, the cell ID this has this azimuth, and the LAC is this one, and so on. This is over all the network that we have. It is provided with let's say this analysis saying which is a co-channel cell sharing the same BCCH, and then the closest cell related to the adjacent channel inferior and superior. The same is for the DCS 1800 megahertz band. So we have the same information. Now, if we want, for example, to see something very quick, very critical, is where we have, let's say, which are the distance of two cells sharing the same BCCH. I mean, co-channel. We are interested in co-channel interference, and the cells are pointing one to the other one. So for this reason, we are going to select only this case from all of this presented here. 1 means source is pointing toward the target and target is pointing toward the source. So this is the most critical when one cell is pointing to the other one. We select this case, and then we want to select the minimum case, the minimum distance, to evaluate the worst case, where, for example, a source cell, this cell, is going to have this BCCH number and is going to share the same BCCH with this cell placed at this distance of 1.3 kilometers. So if we want to see this on Google, for example, we just copy the source cell name, okay, and we want to see this in Google. We just placed over the 2G technology and we copy here the cell name. So this was for the GSM 900 megahertz. We are going just to deactivate the DCS and activate the 900 megahertz, and then we just go double click and we go on the specific cell. So it's C1520B, sharing the BCCH 1008. Yes, this is what we have seen here as well. Okay, so now if we just return on Google and let's color a bit different this cell, just to emphasize quickly this cell. So we have this cell sharing let's say the BCCH 1008, and now we want to see where is the target cell sharing the same information. So target cell is this one. Normally, according with the evaluation of the tool, it should be at 1.3 kilometers. So let's return to Google, and if we put here the name of the cell is this one. Okay, so it's very easy. We have seen here we have the same 1008 BCCH. So if we color this cell with a different color as well, sorry, just want to make it easy, something okay. So I think now I'm going to, the mouse is not working properly, but let's hope that we are going to do it right. Okay, so now we see these two cells have been automatically detected sharing the same BCCH of 1008, and they are pointing one to the other one. So that's why it is important to decide, do we want to change for one the BCCH in order to avoid the co-channel interference? Yes. And which is the best one that we can allocate. So in this case, we just open Agileto, we open the module 2.3, yeah. Sorry, apparently we have yeah, we need to, yeah, okay. And now we are going to continue with the evaluation of the BCCH specifically for this situation. So we just take into account, let's say, this cell or this one, depends which one we want to consider, let's say the source. We copy the cell name and we return to the window, and we just copy here the cell name. So in this case we see, for example, it is 1008 is this cell, C 15020B, and carrying on the BCCH number of 1008, and is saying that the BCCH co-channel number is detected, the closest cell to be C 13567C, having this cell ID 3783 and the LAC 306, placed us at a distance of 1.3 kilometers and pointing one to the other one, exactly like we have seen here. So these are the two cells. But now here the tool is already providing which are the best options to choose to replace this original BCCH with this information, with the new BCCH of 996, which is going to detect another cell sharing the same BCCH at a distance of 53.2 kilometers and even not pointing one toward the other one. So if we want to have, let's say, a resolution, a quick resolution, we just export this information in Excel, and the same information you see here, the source cell and the co-channel cell and the distance for the co-channel interference is presented here 1.3 kilometers, one is pointing to the other one, and the optimum BCCH allocation as per regards of the distance of the repetition of the same BCCH for the co-channel mean is 53.2 kilometers. So if we want, we can replace the BCCH 1008 with the new BCCH proposal, the optimum one, to be 996. And we have we have here the information for let's say the adjacent channel inferior value, means 1007 in our case, which is a cell name, cell ID, LAC, and the distance, and how it looks like pointing one to the other one, source versus target. And the same for the adjacent channel superior number for the cell name, cell ID, LAC, and so on. So this is something that we can change in order to achieve the maximum repetition, the maximum distance for the BCCH repetition. So this is something that we can do. Another thing that we can do as well is to evaluate, as we have already done at the beginning, so it is to evaluate the worst cases. So this is a full, if we want to see here, we can return and we can see the full evaluation about the BCCH allocation and the distance at which the co-channel, inferior channel or superior channel are placed in terms of cell target, cell name, cell ID, azimuth lock. The same thing can be done for the DCS. For example, for the DCS, if we use the same principle, we are going to choose just, let's say, the cells which are pointing one to the other one, and let's take the closest one, that is 1 kilometer. So in this situation, we will have, this is like a source cell, and we return here. So this is the GSM 900, but if we want to work with the DCS, just try to load everything. So we are going to deactivate the 900, and we are going to just see where is this cell 788 as BCCH. Okay, so this is it's quite easy. This is let's say the source cell, and if we color a bit different just to emphasize quickly which is the cell that we are talking about, this one. And if we return here for the target cells sharing the same BCCH of 788, so C 10,662C. So if we return here, and if we put here the name of the target cell, so is this one. If we just change the property, and we see now again we have this we have a case where we share the same BCCH allocation for two cells which are pointing one toward the other one at a relative small distance. So it is up to us if we want to change, and if we want to change the BCCH of one cell, the answer is here. We just put here the cell name of the source, and in our case is C 10,662C is this one, and sharing the same BCCH 788 with this cell C 10,584A. So or we can take this one, for example this one, and put here, and we have this case 10,500 C 10,561B, having the BCCH 788 and sharing the same BCCH with this cell C 10,662C, that is this one. Yes. So more or less this is the way how we detect the co-channel interference critical situations. And in our case it is proposed, let's say, to change the BCCH of 788 with the value of 849, and in this case we will have the repetition of the same BCCH for a cell placed at the distance of 110.6 kilometers. So it's very simple to see, and if we want, for example, to allocate for all of these 3 cells from the same site with the optimum value, we just click here, auto assign input BCCH equal optimum BCCH, and then we will have this information allocated as automatically with the optimum BCCH values, and then we will see here the co-channel closest co-channel cell number, inferior and superior as well information. And if we want, we can export this information in Excel just pressing these things, and we have here and the information was just exported here. Like we can see, the same information that we can see here is here exported in Excel. Now this is let's say one topic, but now if we want to do another exercise, let's suppose that we close what we have already open here, and we have a real situation when we have a rollout. And when we have a rollout, let's say we want to integrate a new site, and I will show you immediately what I am going to say. We want to integrate a new site when we don't know what frequency allocation, one BCCH frequency allocation we want to allocate. So in this case, let's suppose that we have the information of the new site with the minimum data, like we can see, for example, we open this in Windows Explorer, and we have, let's say, this information of the new site to be integrated, presented like here. For example, we have the information about the sign name. Let's say this is called site test, the cell name for each cell. Yeah, we have the information about latitude, longitude. We have the information about the azimuth of each cell, cell ID, LAC, and the BCCH allocation. We don't know which is the best, which are the best value to allocate. So we just put here whatever we want, doesn't matter. And if we integrate this and we map it on Google, we will see immediately where it is placed and which are the situation, the problems that we can face. So let's suppose that we want to integrate this site into our network. In this case, we just first of all need to update the reference database. Okay, so we just say by using an external Excel file, and we use this file, new site, as I told you, already prepared in advance with the information that we wanted. So we say OK, and we choose to update Agileto database with all the new cells and data contained into the external Excel database file. Okay, we say OK, and then for the 3G and 4G information we have nothing, so we do not touch them. Here there is nothing selected. For the 2G information, we select what is available to be inside of the sheet 1, and here we have the headers of the data that we can have use as an input. So for the cell ID, we can use this line, cell ID. For the long WGS84, we can use the column called long. For the lat WGS84, lat. Azimuth, AZ. And for the site name, this value site name, for the cell name, and for the BCCH, the BCCH. And more or less these are, let's say, the minimum value that we want to provide in order to integrate a new site and to map it on Google. We say just OK, go forward. No update is performed for the 3G, for the 4G database, and now it was already created. Let's generate now the MapInfo and Google Earth database after we have integrated the new site into the database. So we just put everything like this by default, and we just wait to prepare and to generate MapInfo and Google Earth maps with all the cells and all the sites that have been let's say detected into the database. So if we do this, we can see now, for example, we can check which is the new updated database for the 2G. We just open the database like this, and we go to the 2G information, and we see here okay, we have forgotten to provide, let's say, the LAC information. That's why there is no information here for the LAC. But anyway, these are the line corresponding to the new three cells related to the 2G technology that were just integrated into the database. So we want to see these cells now in Google. So for this, we just open this, and we use this option to see in Google. And for example, we take out 2G, 3G and 4G, and we leave only the 2G. And if we want to see this, let's say so this is a test site. Okay, this is a test site that we want to see. It was integrated because it is named to it is used to be named as a test site. As we can see here, these are the cell number 2, this is cell number 1, this one is cell number 2, and this is a cell number 3. So we have allocated randomly, let's say, the BCCH values, but as we can see here now, there is a problem. Is a co-channel interference between this cell and this cell. They are sharing the same BCCH number, 1018. So what we can do in this case, we can just go quickly, evaluate which is let's say the situation for this specific new site integrated. We just open the module specifically for the 2G technology BCCH channel allocation, and we just open the status for so this is our cell, our problematic cell that has repetition of the same BCCH. So we just color a bit different, just to emphasize the repetition. So these are let's say the cells which are going to share the same BCCH. So this is a new site integrated, and there is a conflict of the co-channel interference with another cell pointing one versus another one. So what is going to do, we want to see, this is a cell name cell 2, and we want to see, we just copy here the cell number 2, and we see apparently here it was taken the same value for the BCCH. It was automatically given, let's say. But if we take let's say reload original BCCH data, normally we just press this button to reload original BCCH data allocation, and we see initially this site has been provided with these BCCH values: 1021 for the cell 1, 1018 and 1016 for this cell. And this is a cell sharing the same value of 1018 with this cell. So it is C13656C. More exactly is this one. So that's why we have here not only the detection of the problematic cases, cell 2 with this cell, but even the solution as well. So instead to use this set of BCCH values, 1018 for example, for the new site, 1021 cell A1, 1018 cell 2 and 1016 cell 3, it is proposed, because we have here the conflict with the BCCH here presented at 0.7 kilometer. This is the distance between this cell and this cell, 0.7 kilometer, and one is pointing to the other one, means source is pointing to the target, means this cell, it is placed inside of the coverage area of this cell. That's why you have 1 0 here. And the solution is to replace these initial BCCH values with the proposed optimum BCCH values, and in this case we will have a repetition of the same BCCH value at this distance, 54 kilometers, 50 kilometers, 50 kilometers. So what we need to do, just do export the display results. We just export this information, and all of this information is going to be presented in Excel, and rather we can modify the values of the BCCH allocation according with the optimum value. What I want to say just before finishing this tutorial, we can play as well here with the value of the BCCH input, and as far as we change the information here, all this information is going to be updated for the co-channel, the distance and the cell. For example, in live. So once we change the BCCH input, we see the calculation of the closest cell for the co-channel, inferior channel and superior channel perform immediately, and we can play as we want. So more or less this was what I wanted to present you for the 2G BCCH channel allocation, audit and optimization. Do not hesitate to send us your feedback or the issue you may face in practice. I hope it will help you to provide the right, let's say, planning for the BCCH allocation. Thank you for watching, and do not hesitate to send your feedback at support@agileto.com. Bye bye for now.